Welcome to this explainer. Today, we're going to absolutely demystify MySQL. And hey, we aren't just going to sit here and stare at dry, boring code. Instead, we're going to learn by actually building a digital car dealership together, step by step. By the time we're done, you're going to understand exactly how relational databases structure the entire world around us.
So let's kick things off with the really big question. How do we move from a totally chaotic pile of information, random receipts, messy employee files, and vehicle specs, into a perfectly organized digital filing system where absolutely nothing gets lost? Well, fixing that chaos is the exact magic of a database.
Here is our quick roadmap for today. First up, the MySQL blueprint. Then, building your tables. After that, managing dealership data. Then we'll move into asking data questions, and we'll wrap it all up with connecting the dots.
All right, jumping right into Section 1, the MySQL Blueprint. We've really got to lay down the foundational rules of how MySQL organizes information before we can start building our showroom.
The best way to picture this whole thing, think of the database itself as the giant main filing cabinet for your entire business. Inside that massive cabinet, you have specific folders, and in MySQL, we call those folders tables. A table is just a collection of rows and columns holding related stuff, like a dedicated folder just for your students, or, in our case today, our dealership's vehicle inventory.
Now, before you write a single line of code, you absolutely must follow this brilliant 7-step checklist to design your table's architecture. You can't just toss data into MySQL and hope for the best. You need to name your table, decide on the column headers, figure out exactly what type of data goes in them, set how long that data can be, decide if a field can be left blank, and identify your special keys. Only then do you actually write the command to create it. And for step 3 of that checklist, you'll need to assign one of these specific data types. This tells MySQL exactly what kind of information lives in each column. For example, a car's manufacturing year, that'd be an int, or integer. The price of the car, you'd use decimal of 10,2 to perfectly track those dollars and cents. We've even got specific types for dates, times, and variable character text, which we call varchar for things like customer names.
Okay, Section 2, building your tables. It is time to roll up our sleeves and actually construct our digital showroom floor.
To fire up our workspace, we use these fundamental commands. First, we use create database to literally build our main filing cabinet. Then, we have to actually open that drawer to work inside it, which we do using the use command. And finally, if we ever want to take a quick peek inside and see what folders we've created, we just type in show tables.
And wow, this brilliantly illustrates the result of those creation commands. We get a beautifully structured employee table populated with real data. Look at how clean this is. We have our employee IDs, their names, join dates, titles, and salaries clearly mapped out. Like right here, we can easily see Rashil, our salesman who joined in 2017, is bringing in $25,550.
But hey, what happens if you step away from your database for a month and completely forget how you built a table? It happens. Well, the describe command acts as your trusty structural blueprint. By just typing desk, followed by your table name, like desk student, MySQL will print out your entire column structure, data types, and key constraints, so you can instantly get your bearings.
Moving on to Section 3, managing dealership data. As our business adapts and grows, we have to know how to safely modify our records without accidentally destroying all our hard work.
As your dealership evolves, your database has to adapt right alongside it. We can easily evolve our structure using the alter table command. You can use it to add a brand new column, modify the data type of an existing one, say swapping a character string for an integer, or even entirely drop a column that you just don't need anymore, like class code.
Now pay super close attention to this one. When you need to change existing data, you use the update command, and the absolute crucial point here is the where clause. Look at the top example. Without the where clause, you will accidentally change the birth date of every single student in your database to December 12, 1985. By adding where admin_no equals 123456778, you target and safely update just that one specific record.
The exact same warning goes for deletion. These two commands look similar but have vastly different consequences. Using delete simply empties out the folder's contents. All the rows are gone, but your table structure is totally fine. Using drop table, on the other hand, literally burns the entire folder to the ground, taking both the data and your carefully crafted structure with it. So be careful.
All right, Section 4, Asking Data Questions. Let's dive into some data analysis and see how we can pull out meaningful answers for our business.
To ask really good questions, MySQL hands us this incredibly powerful tool belt of built-in functions. You have math functions to round out awkward decimals. You've got string functions to clean up text, like forcing every customer's name into uppercase. Date functions to easily pull the current month's sales, and aggregate functions to find things like maximum values or averages across thousands of rows.
For instance, we can take those aggregate functions like sum or av and use them on numerical data to get immediate business insights. Here is some actual salary data pulled straight from our salesman records. Using aggregate functions, we could instantly calculate that our total payroll for these three is almost $100,000, or find the average salary with just one quick command.
There's a very subtle but super critical difference in how MySQL handles counting, though. If you use count and specify a column name, MySQL only counts the rows that actually have data in that column. It completely ignores any empty or null records. But if you use count with an asterisk, it acts as a giant blanket, counting absolutely every single row in the table, regardless of whether there's missing data.
To actually ask these complex questions and put these functions to work, you must structure your select statement in this exact logical order. Think of it like a grammar rule. You always start with what columns you want to select, tell it which table to pull from, filter those results with where, sort them with order by, and group your aggregates using group by. If you master this 5-step order, you can pull any insight you want out of your database.
Which brings us right to Section 5, Connecting the Dots. Up until now, we've just looked at single tables, but we are about to unlock the true relational power of this system.
Take a look at our sale table. Notice how unbelievably streamlined it is? When a massive sale happens, like invoice I0001 for over $600,000, we don't sit there typing out Honda Civic or the customer's full address or the salesman's whole name. No way. Instead, it just uses snappy ID codes, D001 for the car, C001 for the customer, and E004 for the employee. This saves incredible amounts of space and totally prevents spelling errors.
Let's move to the next step and see how this builds a totally robust system. We formalize these relationships by declaring a foreign key. By writing this command, we strictly link the car ID column in our sales records directly to the master inventory table. This creates an unbreakable rule. You literally cannot sell a car ID that doesn't exist in your inventory. The database itself is actually protecting your business logic.
Finally, to actually view this connected data together so you can naturally see the customer's real name sitting right next to the car model they bought, we use a join statement. You've got a few options here. You can use a standard join where you specify exactly which columns match, a natural join that automatically finds matching column names for you, or even skip the join keyword entirely by just using a where clause to match things up. And just like that, you've gone from a chaotic pile of dealership paperwork to a robust, fully connected database. With the structure in place, the tables talking to each other through foreign keys, and your new ability to ask powerful aggregate questions, the only limit to what you can learn from your data is the questions you choose to ask. So I leave you with this. What hidden stories is your data waiting to tell you tomorrow? Thanks so much for joining me on this explainer. Keep asking great questions and happy analyzing.